Gift from Zeta Reticuli, Bob Lazar. So, there was some paperwork that indicated that this was from the Zeta Reticuli star system. Now, how they obtained that I haven't the slightest idea. That was printed in the same materials that reference the reactor.
So there was some paperwork that indicated that this was from the Zeta Reticuli star system. Now, how they obtained that, I haven't the slightest idea. But it wasn't just from the Zeta Reticuli star system. It was what they called ZR3. So it was a third planet in that star system. So there was no other information about it other than that's supposedly where the craft came from. Now, is that true? I don't know. I have no way of verifying that. But that was printed in the same materials that referenced the reactor. Now, I looked that stuff up when I went home. And Zeta Reticuli is a binary star, two stars that orbit one another. And it's only visible in the southern hemisphere, and it's about 30 some odd light years away. So that's literally all the information I have about that. I don't know how they found out it came from there.
And you also probably have some suspicions that they give you some disinformation like you were talking about before. Where they would, I mean, if you ever decided to talk about this, they added a bunch of nonsense to make whatever is factual look ridiculous.
Right. Or be able
Details on Zeta Reticuli system can be found in Wikipedia. Zeta Reticuli, Wikipedia. This system is located at a distance of about 39.3 light-years from Earth. n.wikipedia.org. Zeta Reticuli system is at about 40 light-years from us. Light-year, abbreviated as Li, stands for the distance that light travels in a year, at the speed of about 300,000 kilometers per second. Here is our Milky Way map with the current position of our Sun. Sun. Now, to understand the scale, diameter of Milky Way is about 100,000 Li, and the map above has a width of about 1,000 px, that gives the map scale. 1 px equals 100 Li. The yellow spot's size is about 20 px in diameter, which translates into 2,000 Li. Of course, our solar system is 1,000 times smaller than this, and our Sun is billion times smaller, as the yellow spot covers our neighborhood of about 1,000 Li radius. And Zeta Reticuli, which is 40 Li from us, is definitely inside that yellow spot. There are plenty of interesting stars inside the yellow spot. For example, the oldest known star in the Milky Way, Methuselah's star, which is 3 times older than our Sun, and is only 200 Li away from us. Now, besides distances in Li, and in px on the map, we need to understand distances in time. Milky Way stars rotate at a speed in the range of 220 to 330 kilometers per second. That is about 1,000 times less than 300,000 kilometers per second speed of light. For example, our Sun needs 1,000 plus years to cover 1 Li distance. 66 to 65 million years ago, when dinosaurs went extinct, our Sun was at 9 o'clock position on that map, leaving Scutum Centaurus arm. And velocities, by absolute value and direction, of stars change like in this computer simulation. Simulation. Now, we have a big picture, and we can see that our Sun spent the last million years inside the yellow spot, inside which was in a Zeta Reticuli as well. Now, let's zoom into the latest time. Current distance between the solar and Zeta Reticuli systems is 40 Li, and both systems move in about the same direction. So with speed range for each system at about 1/1000th the speed of light, the speed at which they recede from each other is less than 1/1000th the speed of light. That means, even if solar and Zeta Reticuli systems some time back were very close to each other, it was more than 40,000 years ago, perhaps closer to 100,000 years back. For astronomers, who have modern observation tools and powerful computers, figuring out solar and Zeta Reticuli trajectories for the last 100,000 years should be a doable task, just like figuring out connecting flights for a vacation trip is doable for us. That would connect the dots in the human history. Megalithic, of 100,000 ton stones, architecture in Middle East and predynastic Egypt, Dynastic Egypt sculpturing in granite and diorite, with a hardness of 8 out of 10. Archeological finding of these flying saucers crafts, as Bob Lazar was told.
Probably one of the hardest stones to work with in that time would have been diorite, stronger stone than even quartz granite, the rose quartz granite stone. And this diorite stone hardness level measured out of 10, level 8. And of course, nobody would even work with this stone. But this particular statue, which has been analysed by scholars and scientists and masons for many years, is just baffling, because they believe this one side of the face is exactly the same as the other side of the face. No difference microscopically at all. And the only real reason to get that, the only main method of being able to do that, they believe, is utilizing some type of cutting machine, as we probably use something like that in modern day. One side of the face is exactly the same as the other, and even they believe even people who may have created this, and if it was maybe enabled to be create this by hand, you would never get two sides exactly matching, and this is an exact match to the microscopic degree, and it would take something like a CNC stone cutter to actually pull this off. We have actually no idea how they managed to cut diorite with such precision, and as you can see from the computer analysis, that one side is in fact identical to the other, and they have no idea how this could have been done just by utilizing human hands. And these are just the information that we're given. The stones, the little copper chisels and brass tools. This created the Egyptian pyramids and all the major stones and constructions we see around the world, the same method. Just does not add up, guys. Thank you very much.
Read more in Beyond Cutting Edge with Bob Lazar.